Good morning, students. Today again we are going to continue with the differentiation of inverse trigonometric functions. The first question is y is equals to tan inverse root 1 plus sin x plus root 1 minus sin x upon root 1 plus sin x minus root 1 minus sin x. We have to differentiate this. In this form, it is very difficult to differentiate. So what we do, we just use trigonometric transformation to differentiate this. We first will rationalize this. Multiply numerator and denominator by root 1 plus sin x plus root 1 minus sin x. We have multiplied numerator and denominator by this. We are just rationalizing this. So in the numerator, we are getting root 1 plus sin x plus root 1 minus sin x whole square. And here, a plus b into a minus b. A plus b into a minus b. So this is a square minus b square. That is root 1 plus sin x whole square minus root 1 minus sin x whole square. So in the numerator, this is whole square. So a square plus b square plus 2ab. And in denominator, the square root sign is removed. So this is 1 plus sin x minus root 1 plus sin x. This is a square minus b square. So this negative sign becomes positive. So this is 2 plus 2 root 1 minus sine square x. A plus b into a 1 plus sine x into 1 minus sine x is 1 minus sine square x. So it is this. And in the denominator, this 1 is cancelled with this 1. We are getting 2 sine x. So this is plus sine x minus sine x cancelled. 1 plus 1, 2 into 1 minus sine square x is cos square x and root out. So this becomes cos x upon 2 sine x. This 2 and this 2 is cancelled. 1 plus cos x is 2 cos square x by 2 and the sin x is 2 sin x by 2 cos x by 2. So we are getting cot x by 2. Tan inverse cot x by 2. So this is tan inverse tan because we have to get this in the form of tan. So tan inverse tan pi by 2 minus x by 2. Cot x by 2 is written as tan pi by 2 minus x by 2. So y is finally pi by 2 minus x by 2. dy by dx, pi by 2 is constant, so derivative is 0. This is minus 1 by 2. So you see, such a complicated form is reduced to such a simple form. Another one. Y is equals to tan inverse root 1 plus x square minus root 1 minus x square upon root 1 plus square. So we have to use some substitution so that this whole thing is reduced to tan theta form. So what we do, we put x square is equals to cos 2 theta because 1 plus cos square theta is and 1 minus cos square theta can be reduced to cos theta sin theta like that. So x square is equals to cos 2 theta. Then 2 theta is cos inverse x square. Leave it here. Now theta, here theta is 1 by 2 cos inverse x square. Leave it here. Now come to the question. Y is equals to tan inverse 1 plus cos 2 theta minus 1 minus cos 2 theta upon 1 plus cos 2 theta plus root 1 minus cos 2 theta. So this is 1 plus cos 2 theta is 2 cos square theta and 1 minus cos 2 theta is 2 sin square theta. So we have reduced to this form. So we are getting root 2 cos theta minus root 2 sin theta. Remove the square root sign. Root 2 cos theta plus root 2 sin theta. Root 2 is common factor. Remove it. We are getting tan inverse cos theta minus sin theta upon cos theta plus sin theta. Divide numerator and denominator by cos theta. Here you see. Divide numerator and denominator by cos theta. So we are getting 1 minus tan theta upon 1 plus tan theta. Tan inverse 1 minus tan theta upon 1 plus tan theta. And you know this is tan inverse tan pi by 4 minus theta. Ultimately y is pi by 4 minus theta. So y is pi by 4 minus half cos inverse x square, because theta is half cos inverse x square. So dy by dx is, this is 0. This is cos inverse x square minus 1 upon 1 minus x raised to the power 4, and derivative of x square is 2x square. So finally it is minus x upon root 1 minus x raised to the power 4. Next is tan inverse a cos x minus b sin x upon b cos x plus a sin x. Again, we are going to reduce it to some tan theta form. Put a is equals to r sin theta and b is equals to r cos theta. So this will reduce to some standard form. So this is tan inverse r sin theta cos x minus r cos theta sin x. R is common factor. Sin a cos b minus cos a sin b is sin a minus b. So this is tan inverse r sin a minus b, that is theta minus x, and denominator, in the denominator we will get r cos theta minus x. So this is now tan inverse tan theta minus x. So y is theta minus x. Now if you take r sin theta upon cos theta, so we get, this is a and this is b, so we get a upon b as tan theta. So theta is tan inverse b, a upon b. Theta is tan inverse a upon b. Now we'll differentiate this. Y is tan inverse a upon b minus x. Dy by dx is 0. This is 0 because tan inverse a upon b is constant, and derivative of minus x is minus 1. So this is how we differentiate. Next question. Y is equals to sin inverse root 1 plus x minus root 1 minus x. Put x is equals to cos 2 theta. So theta is half cos inverse x. So this becomes root sin inverse root 1 plus cos 2 theta minus root 1 minus cos 2 theta upon 2. So this is y is sin inverse root 2 cos 2 square theta minus root 2 sin square theta. So this is sin inverse root 2 cos theta by 2 minus cos theta minus root 2 sin theta. This is now 1 upon root 2. Root 2 upon 2 is 1 upon root 2 cos theta minus 1 upon root 2 sin theta. Put 1 upon root 2 as sin pi by 4 here and 1 upon root 2 as cos pi by 4 here. So this is sin inverse sin a cos b minus cos a sin b. So this becomes sin a minus b. So this is y is sin inverse sin pi by 4 minus theta. So y is pi by 4 minus theta. Now differentiate this. So pi by 4 is constant, so derivative is 0. And theta is half cos inverse x, and now differentiate. Another one, y is sin inverse 5 by 13 x plus 12 by 13 root 1 minus x square. Again we have to substitute. There we substituted for a and b. Now we'll substitute for 5 by 13. So put 5 by 13 as sine alpha. So and x as cos theta. If sine alpha is 5 by 13, then cos alpha is 12 by 13. Now let's proceed with the question. This is sine inverse sine alpha. 5 by 13 is sine alpha cos theta plus cos alpha sine theta. Root 1 minus x square is sine theta because x is cos theta. So again this is reduced to sine inverse sine alpha plus theta. Sine A cos B plus cos A sine B is sine A plus B. So this is sine alpha plus theta. So y is alpha plus theta. Y is sine inverse 5 by 13 plus cos inverse x because x is cos theta. Sine inverse 5 by 13 is constant, so its derivative is 0. And derivative of cos inverse x is minus 1 upon root 1 minus x square. So this is how we differentiated inverse trigonometric functions. Now, differentiation of implicit functions. First of all, what do we mean by implicit function? Suppose there is a function defined in xy such that y is not expressible in terms of x or x in terms of y. These type of functions where in two variables where you are not able to express one variable in terms of other variable explicitly, then they are called implicit functions. In this case, we differentiate both the sides and we find dy by dx. Suppose these are the, here you see this function x square plus y cube is equals to 3axy. If you want to express x in terms of y or y in terms of x, it is not possible. Similarly, this function, you cannot separate x and y. In this function also, you cannot separate x and y. So these type of functions are called implicit functions. So when we differentiate with respect to x, so wherever we get y, suppose we are getting y cube, so derivative of y cube is 3y square. And then we differentiate y as dy by dx. We take dy by dx with that. First question, x cube plus y cube is equals to 3axy. Find dy by dx. So derivative of x cube is 3x square. Derivative of y cube is 3y square. But since we are differentiating with respect to x, so we are going to differentiate y dy by dx. And here 3a is constant. So 3a is constant. And for xy, we'll apply product rule. First function into derivative of second plus second function into derivative of first. So we are getting 3 is a common factor. It can be removed. So x square plus y square dy by dx is equals to a x dy by dx plus y. Now what we do? We take the terms containing dy by dx on one side. That is on LHS. So this is y square minus x dy by dx is equals to, and remaining terms on the other side. So this is ay minus x upon minus x square. So y square minus ax is on this side and ay minus x square is on this side, and dy by dx is ay minus x square upon y square minus ax. We take dy by terms containing dy by dx to one side. Next, the function is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. Differentiate both sides. 2ax, 2h is constant, बाहर रख दीजिए इसको, and for xy apply product rule. First function into derivative of second plus second function into derivative of first. So this is x dy by dx plus y into 1. Derivative of x is 1 plus 2by. Derivative of by square is 2by. And derivative, again we are getting y here because we are differentiating with x. So we will take dy by dx. Derivative of 2gx is 2g. Derivative of 2gx is 2g. And derivative of 2fy is 2f. And derivative of y is dy by dx plus 0 is equals to 0. Now what we do? We take the terms containing dy by dx on one side and others on one side. So these are the terms containing dy by dx and others on this side. So dy by dx is minus ax plus by plus g upon hx plus by plus f. Another one. If root 1 minus x square plus root 1 minus y square is equals to a into x minus y, prove that dy by dx is equals to root 1 minus y square minus root 1 minus y square upon root 1 minus x square. So put x is equals to sine theta and y is equals to sine phi. So root 1 minus sine square theta plus root 1 minus sine square y, 1 minus sine square phi, this is actually phi, is equals to a sine theta minus sine phi. This is cos theta plus cos phi is equals to a sine theta minus sine phi. Take this here in the denominator and apply cos c plus cos d. And here sine c minus sine d. What is cos c plus cos d? Cos c plus cos d is 2 cos c plus d upon 2 cos c minus d upon 2. And sin c minus sin d is 2 cos c plus d upon 2 sin c minus d upon 2. So we applied that. This is cancelled and you are getting cot theta minus phi upon 2 is equals to a. So this is theta minus phi upon cot theta minus phi upon 2 is equals to a. So theta minus phi is equals to 2 cot inverse a. This is sine inverse, theta is sine inverse x, this is sine inverse y. So differentiating sine inverse x with respect to x is 1 upon root 1 minus x square, and sine inverse y as minus 1 upon root 1 minus y square. And because we are having y here, so it is dy by dx. And now you can find dy by dx as root 1 minus x square upon root 1 minus x square. Next, if x is root 1 minus y square plus y root 1 minus x square is equals to 1, you have to prove that dy by dx is equals to minus 1 upon root 1 minus y square upon 1 minus x square. Again put x is equals to sine theta and y is equals to cos phi. So we are getting sine theta root 1 minus cos square phi plus cos phi root 1 minus sine square theta is equals to 1. So this is sine theta sine phi plus cos theta cos phi. And sine A sine B plus cos A cos B is cos A minus B. So this is cos theta minus phi is equals to 1. Theta minus phi is cos inverse 1. So sine inverse x minus cos inverse y is cos inverse 1. 1 upon root 1 minus x square plus, because minus here, so plus 1 upon root 1 minus y square into dy by dx is equals to 0. Now put dy by dx on one side, you will get the required thing. Now I think I should stop here. We'll do the next question, next 3-4 questions in the next session. And then we'll start with differentiation using logarithms. For that you have to revise logarithms also. So do these questions very carefully in your FOIA copy, and most of you are not taking the classes seriously. Please take these classes seriously, because we may not get time at the time of your board exams to revise these chapters, to do these chapters thoroughly. So take this time, precious time, very seriously. Thank you.